All right, we're ready. So we're now starting lesson 7. Any questions before we go into the
I should teach him how to say oi. Oi.
I gotta get the quiz open. 1 second.
Okay.
But no, I don't have any questions. I've been studying like all afternoon.
Lucky person.
It's not too hard. Yeah, I am lucky. I'm on my hands.
I have the joy of working 50 hours a week, so.
Where do you work?
I work for Intermountain Healthcare.
Okay. Where? Group meeting quiz. All right.
All right, so no questions from the preparation assignment, right?
Nope.
All right, then let's go through like we have before. Use the normal probability applet, this is question 3, to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places.
I'm still waiting on my quiz to load. Sorry.
Oh, sorry. Then I will be a little bit more patient.
I'm sorry.
That's creepy.
Okay. Oh, that's pretty easy.
Yep,
Let's
just
go open. So they want the whole area pretty much, right?
just on the outsides, nothing in the middle.
Oh, okay. What'd you guys get?
I got. If it's the right side, I got 0.0872.
It's both sides, so it's the right and the left side.
Okay.
I got 175.175.
Yep, that's what I got as well.
Is it this one right here?
Yeah, that looks like it.
Do you did it -1? You did -1 from it?
Minus 1.358.
1745. Whoops.
Yep, that's right. And then you round to 3 decimals, so you get 175.
Oh. .175. I felt like remember last week we one minus both sides gives you the new side.
It just wants to know the area under both those sides, so.
Okay.
I don't quite understand what you're asking.
It was from last week. Let's see.
So can you see my screen, Brad?
Yes.
So we got the z-scores on each side, and then they just want the combined total under the right side and the left side.
Okay, sounds good.
All right, William, let's just go in the same order we did with the last one, and you take on this next question.
Okay, let me get back to the questions. Okay, which of the following will have a smaller standard deviation if 9 observations are randomly population? So the distribution of the individual observations are X sample means, or this cannot be determined from the information given. We'll have smaller.
So X or X bar, or neither.
So X bar is the sample mean, right?
Yeah, X bar is the sample mean.
The other one would just be the individual numbers by themselves.
I think the first one is the population
Yeah.
of all the sample means combined, instead of just the few that we're picking.
Oh, so it would be all 9, the total of all 9 of them?
So, if I'm thinking of this correctly, if I'm understanding this right, what we're I'll just draw a few things real quick. Okay, I don't know if I'm thinking of this right, so let's go back to the book, because I know we reviewed it, so. Like, before going back to the book, I think it's the large X. Or, not the X bar. Wait, no. It should be the X bar is smaller. Because the standard deviation we use for the X bar is the standard deviation of the parent divided by our sample, the square root of our sample size, right?
Yeah.
It's under like a number 2.
2?
Number 2.
The distribution of the sample means X bar?
Yeah.
I think that's correct. And if it's wrong, we'll discuss it and learn it better.
B.
Yeah.
Will you read? Yeah. So question 4, we put B. All right, Brad, will you read question 5 for us?
Okay. Yes, I can. Which of the following results implies that the spread S bar the S small of okay. This declines as the sample. I think that's the central one.
Yeah, the central limit theorem.
It's under number 2 from the book.
Oh, I was thinking the law of large numbers.
So the X bar means the law of large numbers has more to do with, say, rolling a dice. The more you roll the dice, the closer you're going to get to your average of 3.5.
Oh, so,
Right.
okay, I feel really stupid right now. My screen was blocking the bar because I had it scrolled down too much, so all I saw was an X instead of the mean. So it
Yes.
just looked like a number to me. Okay. Central
Instead.
limits, not theorem. Okay, sorry.
That's what I'm looking at.
Okay, yeah, okay. Central limit theorem.
Okay. Information. Use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed within a mean of 150.8 and a standard deviation of 8.8. So, yeah, it's 150.8.
Loves them, mommy.
And sigma is 8.8. All right. Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? So that one's pretty easy. We do 160 minus 150.8 all over 8.8.
I'm going to do this.
High five. Back to keep. Back to keep.
I'm drawing a blank.
Back to keep.
The square root of 160, right?
We're not using square roots in this one yet.
Oh, okay. So it would
this
just
is
simply
the-
be
Yeah, this is the overall analytic for the GRE. And so we're not using the sample means, we're using the normal means.
okay. So we'll go.
Hello.
1.045.
That's what I got.
1.045. Again, 160 minus 150.8. Got that part that divided by 8. And it continues. Is it 1.045?
Yeah, because
Yes.
we're cutting it off after 3 decimal places.
Right. Then the 4. I wish there was a way is it just continues. We could put a line over it.
We could, but because we're putting it in here and they only wanted 3 decimal places, that's what we're going to do. That's what I'm going to do anyway.
Good.
So what is the probability that a randomly selected student will score above 160 on a quantitative portion of the GRE? So what we're going to do is we're going to find the Z-score and then enter it into the applet.
Yep.
Okay. And they want above 160.
So we have the Z-score for
So-
160 already, so we just plug in 1.045 Z-score.
Oh, I got 0.148.
Yep, that's what I got as well.
Oh, okay. Oh, I'm sorry. Because you said 1045, and I thought you said 145, and I'm like, oh, I got the different. Okay, sorry.
It's 0. This one I'm looking at.
Just the top part.
Just this one.
Dinosaurs.
The 0.296.
We're just looking for the area above the highest Z-score. Give me a second and I'll share my screen.
Okay.
That's the part we want.
Oh, great. Why is it doing? Why is it acting up?
Dig up the bones from the non-tidy hole.
Can you show again?
What's that?
Can you show it again to me? That's acting up a little bit.
He jumped on his back.
Okay, so what we did is we took the Z-score that we found in the other one, and we entered that in, and then we wanted to know who was likely to get over 160. And we got about, what, 14% are likely to get over, or 1.148 are likely to get over 160.
0.148.
0.448. Okay. I know I did. Sorry. It was the left side.
Okay. You understand what's happening now?
I was doing both sides.
Okay. Then let us move on. Brad, will you read the next question?
Yes, I can. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the score considering seeing the sample mean of these students' scores? Rank your score to 3 decimal places. Example, if the answer is 0.8976, you will enter 0.898. I think you add up all the scores up and you divide by 0.8. Things 160 plus 175 plus 163 plus 149 plus 153. Is the first part 800?
Yes, that's what I got.
Okay, and we divide by what's the mean of this possibility? I got 164.
160.
Yes.
That's what I got for our sample mean as well.
Did we just figure out? Did we do the 8 point divided by 8.8 is 18.181. You run up to 18.182.
Sorry, go ahead.
So what are you rounding, Brad?
I'm rounding. I did 160. I divide by 8.8. It's 18.182.
I don't think we divide quite yet.
Okay.
So you guys, what did you get for 8?
So we haven't quite gotten the answer for 8 yet. We're working through that. So we get that our mean of these 5 is is 160.
Okay, that's what I got.
Yeah. And then we plug that in. And so what is the z-score corresponding to the sample mean of these student scores?
So, did you get a chance to watch the videos where they did the problems from the preparation assignment?
A little bit, not too much time.
So one of them, he pretty much does the problem backwards to find the z-score from the mean, kind of like algebraically. I'll look and see if I have it right here in my notes.
Don't remember that one, but I think
I'm looking through.
this is how we're going to get our answer. That second part. Let's see. In fact, I'll erase that first question so we don't get in the way anymore. So we're doing it similar to how we found the z-score before. This time we are doing the dividing our sigma by the square root of our n.
Okay.
Am I thinking right? And that's what it's asking for?
Yeah, I think so.
Okay.
Use or is my one 5 or oops 4 5 is
So I got 2.338. And I plugged all that in.
okay. I think I know how you did. You did 160 minus 100.8, and you got the 8.8. Then divide by 8.8, you square root the 5.
Yeah.
Is that correct?
Yeah. So we have the 8.8 divided by square root of 5 underneath the 160 minus 150.8. And that gives me the answer of 2.338.
So this is where you throw in the square root step
I believe so.
at the end. Okay.
Try it.
Probably. Or you want me to read question 9, or whose turn is to read?
I think it's my turn. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? I believe this time we just plug in this z-score and get the area at the top end of the curve again.
Z-score being 2.338.
Yep. Once it rounded to 4 decimal places.
And they want to know how many will get greater than the mean.
Yeah. So the question is, if you pick 5 people randomly, what is the chance that they will have a mean score above 160?
Is there another part of it for the area?
It's the area under on the far right side.
0.0097 is what I got.
And that's
Yes.
what I got as well.
That's not very likely, is it?
Nope. It's less than 1% likely.
Yeah.
All right. So suppose that the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected?
Approximately normal.
I would agree.
Yep.
Because it's over 30, pretty much, is the only reason I think.
Yep, that's
Do you guys have any other reason for that?
no, that's the basic rule we have to go by. So, all right, William, do you want to read question 11?
Yes. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? So, where's the mean of the distribution?
Okay. Let's see.
Okay. I kind of want to say 3.5, but I know I'm missing something. It won't be that easy.
Oh my goodness. She was right here for a while.
Yeah, it's 3.5. And
Yeah.
My brain shut down there for a second, and I couldn't figure out what it was asking. But yeah, the mean of the subset of all of them would be equal to the population. All right, Brad, will you read question 12?
Yes. What is the standard distribution? The standard distribution is essentially example means the central distribution for all possible examples can be drawn from the parent distribution. Name your answers to 3 decimal places.
Um, so the area, is that what they're asking for?
No, they're asking for the standard deviation. And so we have
It's
the
not-
standard deviation sigma, which is 0.7. But
Yeah.
we need to know what it is when we have 81 students. So it'll change a little bit. So any ideas?
Did we work this one backwards? Standard deviation.
Now this one we have a simple equation for in lesson 7, just at beginning of part 2.
So I'm looking through the chapter right now, so
So the standard deviation of a random variable is also x bar.
Is the value minus mean just the standard distribution? Number 3.
What was your question, Brad?
what about
I think it's under number 3. The formula.
London Bridge is falling down, falling down, falling down. London Bridge is falling down.
I think we use that formula again. What is it doing?
So I see one equation that says the standard deviation of the random variable x bar is the standard deviation divided by the square root of n.
Mm-hmm.
Is that the equation we need to be using right now?
I believe it is.
Okay. So it would be 0.07 divided by
9.
9.
9, because n is 81. Each square root that is 9.
Yeah.
It's,
I got 0.007 or
it's
8.
close. It's 0.7, not 0.07. Or normal sigma.
I got, when I just did that, I
You
got
input the
0.008.
no. You in your equation you put 0.07. You should put 0.7.
Oh, 0.7 divided by 9. Okay, 0.08.
0.078.
Yeah, 0.7 give. This one had. Part is 0.07777 and
I'm sorry.
No worries. Yeah, we'll be done here in a few moments. We just have 3 questions left.
So is the average GPA 3.3? 3.5.
Okay, what is the probability that the mean GPA for 81 randomly selected students will be less than 3.3? Okay. So
what number?
So what we're going to do is we're going to redo question number 10 or
I'm
11.
recording Allie for school.
Okay.
Sorry about that, guys.
We're going to redo question 11. And just do it with a different standard deviation, right? Or I mean, I'm sorry. Yeah, different GPA. Does that make sense? Am I making any sense right now?
Question 11? No, we're not doing question 11. Because question 11, we just said whatever the standard mean is for the parent population, it's the standard mean for the other population.
Okay.
But we are going to use the z-score equation, but we're going to use our new sigma instead of the old sigma. So we're going to use 0.078 instead of the 0.7. And then we'll plug in that z-score to our
Are you trying to steal my guitar? Please steal my guitar. Are you trying to steal my guitar?
At the bottom part, 0.077777777. That's number. That's then 0.7 divided by 9. That's where I got the bottom part.
I got 0.005.
Just by simply doing minus.
Using our z-score equation with the new standard deviation.
Yeah.
That's 2.5.
Yeah, and then plugging that into our probability applet.
Oh gosh. Okay.
One moment, guys. Alex, serious.
Bye.
I'm in a serious college class.
0.0052.
Yep, and we round it to 3 decimal places.
0.5.
So 0.075 is what you got for 13. And you just did the z-score and then plugged it into the...
13, I got 0.005.
Okay. I'm sorry. Okay. Probability of the randomly selected. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? Which would be both areas shaded in doing the same thing.
1 minus the other one, so 0.995.
0.95 or 0.
995.
Oh. Okay.
9.0.
So the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower.
Is number 13? Is that number 13?
13 was 0.005
9.48.
and 14 was 0.995.
Was that 13?
13 was 0.005.
That's what I mean with okay. What was number 12?
12 was 0.078.
0.78.
0.078. 0.078.
That's what I mean. I thought we were working on number 13. Number 12 still. That's right.
Oh.
0.078 for number 12. That's correct. Number 13. 0.005. And number 14.
And number 14 was
It's it.
0.995.
Oh yes, yeah, I'd run at 8 level. 0.995. Okay, now is it my turn now for number 15? Or
Yep.
I'm the average. More, but visit constant energy distribution of passengers is 26.7. The weight of assuming reported determined to be under find pliability to be more sense either above or below the mean. Then we'll observe example. 185 minus.
So we have our 177.6 pounds minus 185. all over 26.7.
So
We're really picking up your wife pretty loud. Okay, so we have 177.6 minus 185. Thanks, William. Divided by 26.7 divided by the square root of 48. That will give us our z-score that we'll use. So let's plug that in real quick.
Minus 177.6. How about do 6.7 divided by, where's my square root?
So I got a z-score of negative 1.92. Oh.
0.9.
So it wants the area of the curve both above and beneath that.
Five, 7, 6.
I have a probability of 0.0549. So it wants it to 3 decimals, so 0.055. That's what I got.
0.555. Is that correct?
I got 0.055.
Whoops. Okay.
William, you're muted if you're talking to us again.
and your z-score is 1.92,
Yeah, that's the one I got.
and you want the area under and below.
So we want
That
the
thing, I
area
got-
on the far left and on the far right.
Oh, over and above, over and below. Okay,
Yeah, we're looking for the extreme values, which are the values on the end.
yeah. 0.55. Okay. You want me to submit?
I submitted and we got one wrong. We got question 5 wrong. Of all the ones to get wrong, which of the following results implies that the spread in X decreases as the sample size increases? Think you might be right that was the law of large numbers.
It was the law of large numbers. Okay.
It might be. I think it is.
I'm gonna submit, and we'll see if we're right.
Did you switch to the law?
Yeah. Yeah, that was right. It was the law. It was the law of large numbers.
Okay. Excellent.
All right.
Well,
Thanks for
thanks,
all your help.
guys. Yep, and we'll try to get a hold of Daniel and see if we can get him in this next week.
All right.
All right, talk to you later.
Bye.
Bye.